So I've decided to make a mini-series all about linear algebra, and you may wonder what linear algebra actually is, and it's all about vectors and matrices and transformations and such. But today we're just going to be looking at vectors, what they are and how they're used. So vectors are typically written as a tall bracket with one number above the other. This would be a two-dimensional vector. You can have any dimension of vector you want, and you would just have the vector that tall. Also, I should mention here that the top number tells us how far right we move, and the bottom number tells us how far up we move, when negative numbers will just mean left and down. So essentially there are two types of vectors, position vectors and direction vectors. They are very similar but different. You can imagine a position vector being a description of how to get to a coordinate. For example, in order to get to the coordinate 1, 2 from the origin, we have to move 1 right and 2 up. So you can almost imagine a position vector as just being a coordinate. However, a direction vector is a vector that describes how to move from one point to another. So say we had the direction vector 1, 2, we can apply this vector to any point in our coordinate grid, and it would translate that point. For this vector, it would move it 1 to the right and 2 up. So if we translated the point 1, 1, the new coordinate would just end up being 2, 3, as we have added 1 to the x coordinate and 2 to the y coordinate. Now we can write things a bit more mathematically and combine our knowledge of position and direction vectors. Say we had a coordinate xy, we can write this as a position vector xy. Now say we have a direction vector AB, and we want to translate our position vector by our direction vector. We can add our two vectors by just adding the numbers across the tops and bottoms, and place these values into a new vector, x plus a and x plus b, which will be the position vector of our new translated coordinate. We can use the power of vectors to solve tricky geometric problems and form geometric proofs. We can also use them to translate entire graphs, but for now, I'll see you guys later.